NumPy package provides basic functions for manipulating large arrays and matrices of numerical data. The scipy package extends the functionality of NumPy. To be specific, scipy is a library that uses NumPy for more mathematical functions. Scipy uses NumPy's arrays as the basic data structure and comes with modules for various commonly used tasks, such as linear algebra, integration, ordinary differential equations, and signal processing. In this video, we will go through a couple of examples to show you the scipy integration module. Numerical integration is the approximations computations of an integral using numerical technique. The scipy.integrate subpackage is easy to use and allows you to apply many integration techniques, such as general single integration and general multiple integration. So first thing first, before we start, we need to import the appropriate library that includes the NumPy, and then also from scipy.integrate, we import the quad, the double quad, and n quad. This is for the single integration, and double quad is used for the double integration, and n quad is used for the n-fold integration. No matter which integration functions that you would like to apply, at the very beginning, you need to define the functions that you would like to integrate. So here we just define fx as the function, and then I assume we just need to apply a linear function. So I just return x right here. So that means our function is fx equals to x. And we would like to use the quad to calculate the area under this function. So area under this function quad. So there are three arguments that we need to put in. The first argument is the function, and then you need to give the upper boundary and also the lower boundary. So the lower boundary right here, I set it as 0, and then the upper boundary right here, I set it as 2. That means we are going to integrate this function from 0 to 2. So let me print out the area. So here, after the result contains two values. The first value is the area, or is the integral that after you apply the quad functions. And then this is the absolute error terms. That means how much error that you have by using these integrations. So the smaller, the better. Similarly, we can create functions for double quad, and by providing two variables right here, and then I just return x times y. So that means we have a functions that is the multiplications of these two numbers. So here we just calculate the area under these x times y. So again, we need to provide the function, and then we need to provide the boundary for the x terms, and then we need to provide the boundary for the y terms. So similarly, we can just print out the area, and then the result is 25, and then this is the error term. Apart from using def to define a functions, we can also use lambda to define a function. Lambda xy, and then the function is x times y. So similarly, we just copy this, and then you will get the same results here. Sometimes our integrations are not just constant. So the beauty of using the lambda instead of def is that we can also additionally apply lambda lambda functions to our constant right here. So what I mean is that, say for example, we want to have a function for the lower bound, and also we want to have a function for the upper bound. We can just assign a lambda function to it as well. So say for example, we have y, just a constant, just a variable y, and then we have a lambda that is y equals to y times 5, say for example, and then we can apply this function into the boundary right here. So this is the result. So here you can see that the lambda is very useful for non-constant integration bound. Furthermore, we can use AND to help us to perform multiple integration function. So here we need to change it to one more parameter. Say for example, x times y times c, and then we need to provide a list of boundary for uh, this argument. So say for example 0, 2, 0, 2, 0, 2, 0, 5, and 0, 5 here. So you can see the results right here. And similarly, we can also use lambda to perform similar function. So you can see we have the same result here. So that's all. I hope now you know how to perform integration with the use of scipy integrate modules. And thank you for watching.